Okay, so today we will start our lecture number 7, and again remind you that you can access them. I try as soon as possible post the recording on the Moodle. I hope this will benefit the students. I started this in winter 2000 with 2030 and I received good feedback, and last semester also I start using this for this course on the fall, and students, they give a good feedback that they can access the lecture materials as a recording, so we will keep doing this. The Moodle's informations, you have all the information about the course, lecture notes. I try my best immediately after the lectures to post the lecture notes so you can access them. Now, in the previous lecture was before the winter break. I hope you enjoy your winter break. We covered the exception, Java control structures, selections, and repetitions. Today we will go over nested loop. Last time we touched the topics from the service. Today we will try to go in details about discussing the nested loop, what is the information about the nested loop, how we can use it. Then we're gonna discuss how we can compare data types. As you know, in Java we have a primitive data type and we have an object data types. And most of the time we are using a reference to refer to an object. So the variable name of the object data type store only the address where the object is stored in the memory, while the primitive data type stored the actual value. So there was a difference in the way that we can compare the object, especially now after we know how we use if statement, if else statement, and switch statements. And then we're gonna go over generating random variables, and finally we'll discuss array. Hopefully today we can finalize all these topics. In case if we couldn't, we will go for the next lectures. Nested loop, as we discussed last time, we have a nested if statements. We can have if else statements, and then we have if else nested statement. Again, we have a nested loop. So a body of the loop inside another loop. For each iteration of the outer loops, the inner loop iterations should be completed. This is very important information. Most of the students, they forgot this fact. Keeping this fact when you are dealing with the nested loop is very important. For each iteration from the outer loop, the inner loop should run completely. Now, this is an example where we have two while loops are nested inside each other's. And as you can see in these examples, we initialize count 1 to be equal to 1. Then we make sure the condition that count 1 less than 10. And then inside that, we have another while loop where is initialize count 2 to 1. And then we make sure that count 2 is less than or equal to 20. The question is here, we're gonna print here message to the screen. And how many times we're gonna print this message? Keep in mind the fact that for each iteration of the outer loop, the inner loop will run completely. So the outer loop will run 10 times. So for each one iteration from the outer loop, the inner loop will run completely. So for each one of this, we have 20 iterations. That's in total will leads to 10 times 20, 200. Now, test your knowledge quickly by looking to these examples. The best way of approaching these topics of if statements for loop is laid by examples. After we explain the theory behind the for loop, how we can syntax write the for loops, now how we can use it by looking to the examples and also by practice. So now you have two for loops. The outer loops initialize I to 1, then make sure that this loop will keep running as long as I less than or equal to 4. And then at the last statement of the for loop, we're gonna increment I by 1. But the inner loop relies on the outer loop in terms of the iterations. Initialize j to 1 and make sure j is always less than or equal to I now is not declared inside the inner loop, it's declared from the outer loop, and that's the scope of the variable. So still we can use I, because I is already defined in the outer loop, int I is equal to 1. Now you can use j less than or equal to 1, and j plus plus, you increment j. Now, if we look at this, what you are expecting as an output of this. So the first iteration for the outer loop where I is equal to 1, j will run how many times? 1. And the inner loop will be running 1, 2, 3, up to 4. So we're going to expect printing a star in the triangle shape. So the first line, we're going to print only one star because the inner loop will run only once. In the second line, we're going to print a star 2 times because the inner loop is running 2 times. J is equal to 1, and the condition here is j less than or equal to I. Sometimes it's good to be able to use different for iteration or loops statements, if we can call it loop statements. So we have do whiles, we have while loops, and we have for loops. And it's good to see if the students understand all of these loop statements by giving them, let's say, while loop and ask them to generate a for loop equivalent to this while loop. So these questions will test our knowledge about what a while loop is essentially equivalent to this following for loops. So we are giving to you a for loop that start from I is equal to 0, I is equal to 1, and then I less than or equal to 10, and I increment at the end. As you can see inside for loop, we can do 3 things. We can initialize the variables, we check the conditions, and increment the conditions. And then we print a statement. This is only one statement for loops. What is the equivalent while loop for this? In the while loop, we have to separate things because while loop can check only the conditions. So we have to initialize I outside the while loop. So as you can see the answer, integer I is equal to 1 outside the while loop. You have to initialize the variable outside the while loop. The while loop can give you checking for the conditions where I is less than or equal to 10. The last statement, not the first statement, the last statement should be increment I. Here where some students, they get confused. They start while loop, then the first statement inside the body of the while loop is an increment statement, which is a problem because the equivalent for loop is not working like this. The increment on the for loop is the last statement. So that's why the equivalent while loop, the increment statement should be at the end. Any question? These are examples of for loops. It's good to master how you can increment the variables. So sometimes we increment by 3, and the second example increment by 7. It's not mandatory always we increment the variable by 1. As you see on the last examples, we decrement by 3. So sometimes we have to start with a big value and we keep decrement the value. So don't keep in your mind that always the file for loop come with an increment statement. Sometimes you start with a big value and you keep decrement this big value until you find the invalid condition to exit from the for loop. So how many times the first for loop will run? Any suggestions? Yes? 5 times. The second one? 1 times. This last one? You see, that is where the students always got confused, because the for loop is in their mind always going in increment directions. Once you give them a for loop with decrement, they start questions, is this is a valid for loop? So this will run 4 times. Now, I would like you to take 1 minute and try to answer these questions. Here we have testing our knowledge to know how many times this loop will repeat, and actually what will be also printed outside to the screen. Take half a minute and give me your answers. These examples actually highlight the main steps whenever you come across a questions that ask you to trace an execution of any Java code. You have to first focus on the for loops. Do you have for loops on the code? Then know how many times this for loop is running. Then the second part or second step, what is the process inside this for loops? So how many times? 3 times. So this will run 3 times the for loops, and the output will be the first time is 9, then the second is 81 because we are looking at the x and we're multiplying x by itself. Then we have 6,561, and the last statement is not part of the for loop. So for loop is running 3 times. The last one is due to the statement that is outside the for loop. Now, we have this nested for loop, and we initialize integer t capital to be equal to 0. And we run through nested 2 for loops. And we keep tracking the value of t capitals by using the index I and j. The question is, what will be printed outside to the user? You would like to take 1 minute, or you would like to see the answer immediately? Let us vote. Do you like to take half a minute to trace the execution of this, or it's not worthy for you and you need to see the answer immediately? So I assume you want to see the answer immediately. So as you can see here, the j is equal to 1, and then we have j less than or equal to 2 times I. Now, where is I is defined from the outer loop. And the increment is by 2. So once we initialize j to equal to 1, we increment j by 2 at the end of the for loops. So the output will be t is equal to 1, then t is equal to 9, and t is equal to 36, which indicate that the for loop will be executed how many times? As you can see, there is a trick on these questions. I left it for you at home to see what is the trick on these questions. Now, this is a good questions or good scenario for a questions that you might see on the lab test too. We need to write a method. The name of this method is digitSum. That accept an integers. So it's take only integers as a parameters and retain a sum of digits of that parameters. And there's an example is given to you. digitSum, and we give 29,107. So 29107, and we need to retain the digit sum of this integer. How we can do that, or how we can handle this? We have to take each digits separately and add them. So we're gonna 7 plus 0 plus 1 plus 9 plus 2, the total is 90. This is how we're gonna end retaining the result. We assume that the integer is non-negatives, and there is a hint. I like hints. We can use the mod operations to extract the last digits of the number. If we do this repeatedly, we should stop. So the hint is saying that the mod operation can play a very important role in your implementation. You want to ignore it, it's your choice. So as you can see on this slide, and this is one of the candidate questions will be on the lab test, I didn't give you the header. I left it for you. So you have to come up with the header of the method. Okay? Now, based on the description of the method, we are going to receive an integers. The name of the method is given, and we're going to retain also an integer, which is the sum of the digits. And as a hint, always the hint is not mandatory for you to use it. Okay? So you might end up with an implementation that's really no mod operation on it at all. But again, this implementation should give us a task. Let us see some process. Maybe you can, how we can approach this in our mind before we run writing and implementations. And remember our discussions that an implementation will be a sort of an algorithms. An algorithms is a step of statements need to be executed in a certain orders. And we use help of if statements, while loop, for loops, all these if else statement if we need to use. So all these tools we are equipped with to solve these questions. So let us approach the questions. We need to separate the digits. So we need to take the ones digit alone, tens digit alone, 100 digit alone, and then we add them as a value. So if we start with n is equal to 29,107, what will be the mod operation base 10? Yes? 7. And what will be n divided by 10? And this in integer division. So we're gonna ignore the remainders. Will be. So the mod operation will give us 7 alone. And once we divide an integer divisions by 10, we're gonna end up with 2,910. So we are going by reducing the value of the number. We start with 29,000, now we have 2,000. Let us continue using the previous iterations and start asking questions by updating the value of n to n divided by 10. So now the value of n is actually 2,910. So what is the n divided or mod operation of 10? Yes?
0.
And what is n divided by 10? 291. As you can see, through this loop, we are satisfying the condition that the value, the big value, 29,000 is reduced. And we were able to extract the digit value. We extract the ones digit and we extract the 100 digits. We keep doing this. And what is the stop condition? When are we going to stop? When n is equal to 0. When n is equal to 0, this is the condition we have to stop. Okay? So this is the implementation. I'll give you half a minute to look at it, and if you have any questions, let me know. Okay? Do you have any question? So here we are adding to the sum that we initialize outside the while loop to be equal to 0. And in mode 10, which is the digits that we are looking for, we added to the sum at each iterations. And as you can see, the conditions, we update the value for n at each iteration. So we're always going toward a less value, which satisfies that we're going to exit the while loop. We're not going to run to an infinite while loop. Now, what is these for loops print out? The good thing is to notice here that all these three parts inside the for loop, as we discussed last time, are optional. It's not mandatory. Don't raise your hand saying, oh, the second for loop, there's a missing information. Most likely this will generate a compile error. No, all these three parts, initialization, conditions, and increment inside the for loop are optional. So the compiler will not generate a compile error if they are missing. As you can see in the second part of the for loops, we are forgetting about the initialization and increment, and we have the increment actually inside the body of the for loops. We can do that. So the first for loop will print 1, 2, 3, 4, and 5, and the second one is equivalent to the first one. Okay? Now, what do this for loop print? So what do you think will print this one? Any suggestions? Yes? 2, 3, 4, 5. So this print 2, 3, 4, 5, 6. The only trick here is the increment was the first statement before the printing out. So we are incrementing I before printing it out. Now is very important topics. It's about comparing data types. So far we covered the primitive data types and object data types. So to compare a float or doubles, most likely you're going to use double inside your code. We need to avoid using equal equals because double and float are represented by digits inside the registers inside the computer, so there is no accurate value of a representation for any real number inside the computers. To demonstrate this, we're going to see some examples. So equal equals will not work with doubles. Even double is a primitive data type, so once you define a variable with double data type, it will store the value in that location in the memory. It's not a reference location. It's an actual value. So we need to avoid using equal with the double and float. It's better to make sure the difference between two double numbers are slightly less than some thresholds, then we can say these two values are equal. For example, 1.9 is not equal to 2.0. But if the threshold was 0.1, so the difference between them is 0.1, and I say if I have two double values, difference between them is 0.1, I will consider them as equal. So it's good to use this approach in these situations. So to determine the equality of two double values or floating value, we're gonna rely on the absolute difference between them. So we have F1 and F2. We take the absolute difference between them with the help of the math.absolute value functions. So if this difference is this than some value or a threshold or a tolerance that we can understand it inside our application or inside our app, then we say they are equal using the threshold value. Sometimes you can take the threshold value is actually 1 times 10 to the power 6 or 10 to the power minus 5. This is an example to demonstrate the fact that I discussed about, that any computer will not represent a real number exactly as is. This is two approaches to find a value first F1 is in start with 0. We initialize F1 as a double with 0. Then we go through the for loop and we add how many times? 11.1. So you start with 0 and using for loop, you add 0.1 to F1 at each iterations. In the second approach, we are using F2 and we take 11 times 0.1. Do you think what will be the value for F1 after the finishing for loop? And what is the value of F2? It's supposed to be the same. Is that right? Let's see the computer how they understand this. So after that iteration, F1 will be 1.0999 up to the end, while F2 is actually 1.1. So if you are relying inside your Java applications that I'm going to use equal equal to compare two double value, you fail. Because these two, F1 and F2, they are not equal. So if you are having two double numbers and you try to compare between them to see for equality if these F1 is equal to F2, is not a good approach to use equal equal, and this example is highlighting this issue. So how we can approach this questions and how we can compare double value? We use the absolute difference. We rely on the absolute difference and we define a threshold value that we are happy with. If the threshold value is 0.001, which is 1 times 10 to the power minus 4, then I say the two double values are equal. And by running this, the two numbers are equal based on the threshold value that I define. Okay? Any question? Okay. Now, we have the car or a character type also. The good thing about the character is a Unicode, that most of the programming languages Unicode or abbreviation of a subset of this Unicode is called ASCII code. So the character actually is represented inside the computer as an integer value, not as really a character A or P. So you translate this. So we can use the relation or rational operator with the character because they are represented as an integer value. So we can ask if this character is greater than this character, if this character is less than this character. So we can use all these kind of things because these are just like numbers. So a plus characters, I put it between one code, single code, is less than the J capital characters. We can do this because Java used the ASCII code to represent the characters. So the ASCII code is just an integer value and we can compare the integer value. Now, it's good to know the ASCII code, that's the good things about ASCII code, is continuous in terms of assigning the integer value to the characters. So number 9 is a character, number 0 is a character. So the ASCII code between 0 and 9 are continuous from 48 to 57. So number 9 is represented actually inside the computer as an ASCII code equivalent to 57. Now, A capital and Z capital, they have a continuous range of an ASCII code from 65 to 90. A small and A Z small is from 97 to 122. As you can see, the A capitals in terms of the integer value or ASCII code is less than the A small value. So having this in mind, we can test our knowledge on these examples. We have 3 characters, 1 and 2 and 3, A, and P. We assign a value to them. We initialize them and we assign the value. And then we ask to print if the character 1 is equal to character 2, and character 1 is equal to character 2. Then I go one more step to use the wrapping class that we discussed in the previous lectures. The wrapping class is taking a primitive data type and put it inside the object class. As you can see, I define a new character, which is the full word with C capitals, and a new, use the constructors, a new character, and assign ch1, which is the first characters. And then I define a character object 2 and character object 3. Now, the first 3 lines on this code define a primitive data type, and line number 5, 6, and 7, and 8, they define an object characters. There is a difference between how we can compare a primitive data type and object characters. Object characters always rely on dot equals methods. So we have to implement our method to make sure these two characters are equal. So the character wrapping class is created by Java Expert. So dot equals method is already created for us. We don't need to worry about it. So we can use it. So what do you think the output of this? Is character 1 is equal to character 2? What will be printed from the first print statement? True. The second one? False. What about the last two? You think the people of Java Expert, they implement equals wrongly? Or you have never seen this before? It's okay, if you're not seeing this before, you can try practice this at home after the lectures. So still, the wrapping class give us an accurate implementations about dot equals. So don't worry. So even if you take the primitive data type and put it inside the wrapping class and use dot equals method, you will have the correct implementation. Still, character 1 is equal to character 2, and the object character 1 is equal to the object character 2 because the state of that object is the same. The state is A capital. Comparing a string. A string is an object data type. We cannot use equal equal with a string because it's an object data type. We have to use dot equals, as you see on the previous examples that we are using dot equals with the character wrapping class. So we cannot use equal equal with the strings. We have to use string dot equals, and we give the name of the string and to make sure that these two strings are equals. So not only this, but if you would like to know if this string is less than the other string, you are using compare to. Compare to will allow you to make these objects in orders. In the integer data types, or a primitive data type, you know that 1 is less than 2, 2 is less than 3. You put the integer value in an order. Now, if you create an object, and this object is a string object, how you know that this string is less than the other string? Java Expert allow us to use compare to methods. Compare to methods allow us to determine the order of the strings. So if the name1 dot compare to name2 will retain an integer value. This integer value is equal to 0. That means these two strings are equal in order. So the name1 is equal to the name2 in order. And there is a big question mark here that don't rely on compare to if they retain an 0 for you, that these two strings are exactly equal in terms of the state. But let's say compare to will make things in order. It will let me know that this string is before this string in an order. You want to sort out the students in terms of height, measuring the height, then you put the students in the term of height, or you want to sort the students in the grades, you have the grade and you sort the grade ascending or descending orders. Okay? Now the same thing, you have a strings objects and you would like to sort these string in ascending or descending order. You rely on dot compare to. Dot compare to is not the same as dot equals to measure the equal in terms of the state of the string. It will allow you to make sure that these string in term of order, they are the same order. If the value is returned from compare to is negative, then we have an idea that the name 1 is less than the name 2. If the return value is positive, then we have name 1 is greater than the name 2. So compare to, the behavior of the compare to is very simple. It will return 0 if they have the same order, the same height, the same grade. The two string or two objects have the same order. If the name 1 less than name 2, we have negative value, and if the name 1 is greater than the name 2, we have positive value. We're going to come to that next slide. Next slide, it will highlight how we compare these strings using the lexicographical orders. Now, this will consider the length of the string, the content of the string, on the way of comparing the two strings. How this happened, just more notes about lexicographical orders is, as you can see, we not strictly alphabetic orders, so that when the uppercase and lowercase character are mixed up, the string grade come before fantastics. Why that? Because all the uppercase characters is less than actually the lowercase. As we saw in the previous slide, the ASCII value of the lowercase, they have an integer value less than the lowercase. So immediately when I see G capitals and F small, lowercase, then I realize that the grade is, in terms of the order, will be less than the fantastics. Book and bookcase. The first part are the same, but now the short string come before the longer string in terms of order. So book and bookcase. So the book come before the bookcase because it's shorter. So they have the same beginning, but the bookcase has more strength, so in terms of the value. So now, I encourage all of you to go home and try to practice putting strings and try to see what the behavior of compare to, which ones compares than the other. These two examples will highlight the fact. So just to summarize about the topic of comparing objects, equal operator can be applied to an object, but remember the issue of aliasing. When you have two objects, when you are using two objects and use equal, you are comparing if they are referring to the same object. So because the object data type variable is stored the address of the memory where the object is stored. So if you have two strings and make equal with two strings, you are saying that if they have the same address on the memory. Dot equals is a very efficient way to compare two objects. If you declare an object of type rectangles with the width and height, you would like to make sure that two rectangles are equal. You implement your equals method and you make run for dot equals method, not equal operators. So it has been redefined for the string class by the Java expert to compare the two strings. But if you write your own class, like rectangle class, we saw in the previous lectures, you have to provide your own implementation for dot equals. So this is back here, the rectangle class that we discussed last time. Just to remind you, we have two instance variables, which is the height and the width, and we have a constructors to take width and height and assign them to width and height once we construct the object of rectangles. And we can get the height, get width, and also get area, and get circumference of the rectangle. As you can see, we have override to string. In case if we would like to print a rectangle out to the user, we say the rectangle with the width, and we give the value, and height, we give the value between the braces. Now, look at that what equals. Once we create our own class, if we didn't provide the implementation for equals, the Java application will use the default implementation of dot equals. And the default implementation of dot equals is very risky because it's compare the addresses. It's not comparing the state of the object. We say that if two rectangles are equals, if and only if the width and the height of these two rectangles are equal. So as you can see in the using if statements, if the get width equal to equal get width, and the get height is equal to get height. So two rectangles are equal not because they have the same area. They are equal because what? They have the same width, the same height. Any questions about rectangle? This is our own class. It's not created by somebody else. We create the class, we provide our own implementation for equals. So we can compare the two rectangle objects together. Now, we run this example to test our knowledge. We have rectangle A, rectangle B, and rectangle C. As you can see, we call the constructor, we initialize the width and the height for each one of these rectangles. And we use equal, equal, and we use dot equals. I would like you to take half a minute and think about these examples. What will be the output? Any suggestions? So the first print statement will check rectangle A equal equal rectangle B. So by doing equal equal operators, we are checking what? We are checking the addresses if they are stored in the same address, and that will retain false because these two independent objects are stored in totally different addresses. Yes, we already saw examples about that. It's when you are using aliasing. When you're trying to make an aliasing, when you assign two variables and both are pointing to the same object. You define rectangle A, then you say rectangle B is equal to A. So both are pointing to the same one. But now we have, using new operator, we construct independently three rectangles, and all these three rectangles have different addresses. So the first two statements will retain false, and the first one dot equals, it's clearly that the width and the height for rectangle A and P are not equal, so dot equals will retain false, but the width and the height for rectangle P is this and C are the same, so we return true. And if we are using dot equals with P method, which retain the same, that is the beauty of dot equals. Should doesn't not affect which one is calling the dot equals. Rectangle C dot equals P should return true. If this is returned true, if I use rectangle P dot equals rectangle C, should return true. This is one of the things that we highlighted on 2030 when we implement dot equals methods. Now, I go to the second version of rectangles. I re-implement the compare to on the last part. You can see I public integer compare to, I give a rectangle. This is the second version of the class rectangles. And then I ask if the area of these two rectangles are the same, I will retain 0. If the area is greater than the other area, I will retain 1. Otherwise, I will retain -1. So this is very good examples where you see the difference between compare to and equals. When the compare to, in this case, retain 0, what that mean to you? They are equal in terms of area, but they are not equal in terms of the width and the height. We might have rectangle, they have different width and different height, but they are the same area. So don't keep this in your mind. Always remember, compared to is not the same as equal. So once you implement your class, you have to define what is the equality conditions. When I have two chairs, they are equal if they have the same color. That's enough for me. But if I want to sort these chairs in terms of order, ascending or descending order, I will look at the weight. If the weight of this chair is less than the other weight, then this should come first. So here we have sorted the triangles or rectangles in terms of the area. So if the area of this rectangle is less than the area of the other rectangles, then we put the rectangle in terms of order before that. Any question? So, for the scope of this course, implementing equals is not your responsibility. Implementing compare to is not your responsibility. The only thing is we're going to ask you is, we give you the implementation and we ask you to use dot equals and dot compare to. You should be able to use them. Okay? So, two rectangles are equal if they have the same width and height. And two rectangles have the same area will retain 0. So in terms of orders, we focus on the area. In terms of rectangle equality, we focus on the width and height. So this is a zoom for the compare to, in case it was difficult for you to read it from the previous slide. This is this dot get area greater than the other dot get area will retain 1. That means this area, this object is greater than the other object in terms of the orders. And if this get area less than the other get area, we retain -1. That means this object is less than the other object. Otherwise, we retain 0. Now, if we test our knowledge on these examples, we define these three rectangles, A, B, and C. And we use compare to. What do you think the output from the first if-else statement? Is a rectangle A dot compared to rectangle B is greater than 0? We look at the compare to implementation on the previous slide. The compare to implementation focus on the area. So, is the area of A is greater than the area of B? No, then which statement will be printed? Rectangle A has area less than rectangle B. Now, is a rectangle C compared to rectangle B have the same area? No. So which one is going to be printed? Which one of these statements? So rectangle C has less area than rectangle B. Okay, any questions about comparing the objects? So if you're going to compare for equality, if we have object data type, we use dot equals. If we have object data types and we would like to sort the object in terms of orders, it's good to use dot compare to for that. Any questions before we proceed? Now, the random class, it's a sorry. random class allows us to generate randoms variables, and once we create the object of a random class, we can use these methods. Next integer will retain a random integers, and this random integers we can use it in our applications. To make a limitation on the next random integers, we use the second method, next integers, and we provide the max value. So the max value will allow us to see an integer value between 0 and the max, where the max is not included. So this is from 0 up to max minus 1. If you would like to use a double random numbers, it's good to use next double, and this will retain our real numbers between 0 and 1. Again, 1 is excluded, so it's between 0 and 0.9999. How we can use the random class? First, we have to create an object. Random equal rand, this is the object name, or the variable name, equal a new random. So the first line on the blue is creating the object. Once you create the object, you can use this object to generate a next integer value. And on the second line, we are using int random number equal to rand.next int, and we provide 10. So by doing this, we are looking for any integer value, random integer value, between 0 and 9. To be able to use the random class, we have to import.java.utility.star semicolon. You can specifically ask for a random class by saying import java.util.random, or you can ask for all the util classes by saying star. So it's random can be used to generate any random numbers as between 0 and the max minus 1. But if we ask you to generate a random number between 0 and the max, where the max is included, we have a special procedure for that. So as you can see, we can generate a random number between 5 and 10, where 10 is inclusive. So this interval is inclusive. So 5 is included and 10 is included too. So we can use rand.next integer 6. So we have now the number between 0 and 5. We add 5 to that, it will become between 5 and 10. If we ask you to give us a random number between 1 and 10, where 10 is included, so between 1 and 10, we can ask next integer 10. So this will retain a random number between 0 and 9. Once we add 1 to it, it's become between 1 and 10. Okay? Any question? And the procedure is clear in this slide. If you have an interval inclusive between min and max, take the subtraction between max minus min plus 1 to make sure you retain the next integer within that interval. So to test our knowledge, I ask you to give me a definition, given that I already defined a random rand equal a new random. So I already created an object for you. You don't need to worry about that. The only thing I need the statement that retain a random number between 0 and 100 inclusive. Then I want a random number between 1 and 100 inclusive. And then we ask about random number between 4 and 17 inclusive. Can you do this? Any suggestions how we can do this? Yeah. To generate a random number between 0 and 100, we ask 100 minus 0 plus 1, that's 101. So we're going to ask round dot next integer, 101. This will retain an integer value between 0 and 100. If you would like to have a random number between 1 and 100 inclusive, you will ask for 100 minus 1 plus 1, that's 100, and then you add 1 to it. That will give you the what you are looking for. It's a random number between 1 and 100 inclusive. Now, the last one is very important. When you are dealing with a random number that's not start from 0 or 1, you are dealing from a random number that starts from 4 and 17 inclusive. So you take 17 minus 4 plus 1, that will become 14, and you add 4 to it. This will give you the random number between 4 and 17. Okay, given this random number to test our knowledge, what do you think the possible output? These are 4 possible outputs. Some of them is wrong, some of them is correct. Which one of these output is correct? Which one of these output is wrong? What about the first output? So what we are looking here, what the random number that we generate in this question? We are looking to generate a random numbers that between 0 and 5, 1 to 5, 1 to 5. So what's about the first one? Correct. Second one? Second one and third one is wrong because we have 6 and we have 0 on the third one. The last one is correct. Okay. Any questions about random number generations before we start array? Yes.
Why are we creating objects? Why not just use random versus creating an object and then making a variable after that?
Okay, this is another way of using a rand class. So what we highlight here is not math.random. We highlight here a random class, and we show you how you can use it. If you are happy with the math dot, it's your choice. But sometimes the questions coming to you is use the random class to do this. So you have to be able to use both. Any other questions? Okay, array is very important. If I ask you these questions, some of the students or some students, he was a little bit curious about knowing how many minutes take to get to university in the 5 days that he is attending the university. So he starts recording. The first day is 45 minutes. The second day is 44. The third day is 39 and 49, 48. Then the last one is 37. Then he started asking these questions. Find the average. What's the average? And then ask a second questions. How many days above the average and how many days below the average? We can do this without arrays. We can define 5 variables, each one for each day, 5 independent variables. We can run through these 5 independent variables. All of them have the same data types. We can find the average, and then we use if-else statement to find how many days above the average and how many days below the average. So this is questions, it's motivation about the arrays. The arrays allow you to store multiple data types, the same data types on the one variable. So you handle this. I can define an array with 5 spaces, and each one of them have the name. So I can access this array with 5 places. So array will allow us to run this questions or solve these questions more efficiently. So we need each input twice to be able to compute the area, the average and the cumulative sum. Also, how many above the average. We could read this from the variables. So what about if we need to do this for a month or for a week or for a year? It will become hard for us to implement this algorithms or implement this problem with the Java code. Because imagine if you are taking a reading for a month, you have to define more than 20 variables. And you have to go through a big line of code to be able to handle all this reading if you decide to use independent variables. Using array will allow us and help us to solve such problem more efficiently. Array is an object that stores many values with the same data types, and this is one of the things we need to highlight. So once you define array of integers, only integer value can be stored in that array. Once you define array of rectangles, only rectangle object can be stored on that array. If you define array of doubles, only doubles value can be stored on that array. Elements, one value on the array. Index always start from 0 of the array. So here is an example of an array of integers, and this array has 10 elements, and the index start from 0 up to 9. Element number 0, the value for element number 0 is 12, and the value for element number 4 is 5. So you need to make sure the array always start from 0. There's no way of starting the array from 1 unless if you skip the first element. But that's how the Java is handling the array. When you ask for an array of 10 elements, it will start storing the element from element number 0. So element number 5 will be at index what? If I want element number 5, index 5, element 0, we start. This is a slide is showing you what is the element, first element. What is the element number 1? What's the value for element number 1 is 49. What's the value for element number 0? So keep that in your mind when you are dealing with the array. So element number 1 is 49. Element number 0 is 12. Element number 5 is 17. So some facts is a single name for a collection of data values. All these values from the same data types. A subscription notation identify one value inside the array. More than a primitive data type, less than the object. So that is sometimes people, you go to them, some reference, some website, they say, okay, when they are discussing the array, they discuss the array as an object. And they start working on the array as an object. But here in this course, we're gonna see that the array has some features like objects, but then you cannot make inheritance from object, which is the topic that you're gonna cover in the next course. So that's why it's make the array less than the object, because we cannot make inheritance from arrays. We can handle the array as we handle objects, but we cannot do inheritance with the arrays. The good and efficient way is for loop or while loop to access these elements, most likely the for loops for the array. How we can create the array inside Java? There is a syntax. You have to provide the data types, then square brackets, name of the array equal new. You see, you call a new operator. That's why some people, they say, oh, this is an object because I create a new object. And then you call the type, the same base type, int, and you provide the length. Now, all these is mandatory. If you skip the length, okay, when you call the constructor, will not allow you to go this. You cannot create an array with a known length. I will define the length later on. You can do that, but if you are using a new, the all full right side, and you skip the length, you say between the two square bracket and empty, compiler will not allow you to do this. This is an example of creating 80 elements of a car object. So car, square brackets, and symbols in new car, and you get 80 elements. And now these 80 elements start from 0 up to 97. You can start 100 element of doubles. Doubles, square brackets, the name, reading, and new doubles, 100. You can have 70 element of rectangles, rectangle data types. So I would like to create 70 rectangles. I have students on the kit, each student draw rectangles. I would like to calculate the average area for these rectangles. It will worth it to create an array, and inside this array, I will store a rectangle object. So array is not always for a primitive data type, int or doubles. You can have an array for an object. So rectangles, square brackets, rectangle array, and the new rectangle of 70. Now, this is allowed, but is not recommended. You can use the same syntax, is data type, an array, and then you put the square brackets after the name of the variables. The Java compiler will say, okay, no problem, but this is not recommended, as you see in this example. You can do it, but it's not recommended. In this slide, just I define a reference, my list, as an array of double, but I didn't specify the length yet. I can specify the length later on when I use a new keyword. So this slide to remind us about the structure of the array inside the Java. When I define my list as a new double of 10 elements, then I have element from 0 up to 9. Element number 5, it's actually value 34.33. This is the element value. So my list is a reference name. My list itself will not benefit anything. You cannot access any element if you say my list, print my list. This is just a reference where the list is stored. To access any element, you have to provide the index with the my list name. So my list will be a reference name for the array. If you would like to access element number 1, element number 2, element number 0, you have to provide a right index. So declaring the array, you can use the square brackets to declare the array integer pressures. You have, so int is different from int with the square brackets. Those are different types. So int with the square bracket is array. Int itself is a primitive data type. To create a new array, a new int, as you can see, I define just int pressures array, a reference. Then later on, I use a new keyword with a number of elements that I would like to reserve for the array. And also I can use the square bracket to access the element. So I can access pressure element number 3. Some terminology we're going to use on this course about the array. The temperatures and then the square bracket n plus 2, temperature is the name of the array. N plus 1 is the index, also called a subscript. Must be an integer. As you see, the index of the array is an integer value. So subscript here should be an integer value. You can provide an arithmetic equations like n plus 2, but it should be always the data type of this arithmetic expression is int data type. Also, the index square bracket, the name of the array plus the index is called index variables, also called an element or subscript variables. So name temperatures with square bracket n plus 1, we call it a subscript variable or an element. Now, you can assign a value to that element inside the array. So 32 is the value of the index variable. What's the index variable in this case is n plus 2 temperatures squared by n plus 2, which is the element. You can see here the element may refer to a single index value variables inside the array or a value of the single index variables. So the name elements is used for both. Any questions about terminology about the array? Array length is one of the attributes or one of the things that is make people also saying that array is an object, not a primitive, but is as I mentioned, it's close to object, but is not object. So when you create a new array and you ask a new, you have to specify the maximum number of elements inside your array. If you didn't do this, the compiler will not allow you to create a new int without specifying the, you have to allocate the elements. Okay? Now, you can access, whenever you send your array to another method, you can access the length of the array. So the array, once you define it, the length of the array is attached to it. You cannot change this. That means array, it's similar to the string object, is immutable. If you want to extend the array, you have to destroy it and create a new array. You want to shrink the array, you have to destroy it and create a new array. So once you create the array, you specify the length and this is fixed. You cannot change it. Yes, I'm not using, I create an array of 70 rectangles, but I'm using only 50. That's okay, but you ask the compiler to reserve 70 space. Like this room, we have all these chairs. All these chairs are full? No, but we have these chairs on the room. So we create the lecture room with this number of chairs. This is the maximum number of chairs on this room. Are we using all the chairs? That's a different story. It's the same thing on the Java. You create the array with a maximum length. You might not using all of them. So here we create a rectangular array with 20 elements. So we have to specify how many elements we need, and this will be at the maximum. In case if I decide that I need 21, at that time I will create a new array. Now, Java expert, they allow us to use some method where allow us to copy an array from a different array to a new array, which is make it life easier. So you can access the length. As you can see, entry.length. There is no square brackets. This is not a method. This is an attribute. You can access the length of the array immediately. There is no parentheses after the length. So, is established at the declaration time, as I mentioned. So once you create the array, you cannot change the length. You specify the maximum number of elements that you need, and this will be fixed. Subscript range, as I mentioned, always start from 0 up to the length minus 1, and this is an indication for array of 4 elements, start from 0 up to 3. Now, what about if I ask for 20 rectangular array, 20 elements, and by mistake I try to access element number 21. In this case, Java provide an exception. We'll check that. So we will have a runtime exception called array out of bound exceptions. So this runtime exception, we cannot detect it at the compile time. We cannot detect this at the compile time that I'm trying to access an element outside the bound of the array. We can see this only at the runtime. So at the runtime, we're gonna have array out of bound exceptions. This is one of the features about the Java. C and C++ will not notify you at the runtime that you will try to access element out of bound. Okay, array length specify at the runtime. I mentioned once you declare the array, you have to specify the number of elements. Sometimes we need to do some calculation inside our program. Then once we do the calculation, we know how many elements I need. So that leads to specifying the number of elements at the runtime. As you can see, we do some calculations about the size, and then we figure out how many elements I need. So the size is updated, then I ask a new integer of the size. So either way, I use it int 10, this is fixed, so I need 10 elements, but sometimes we need to run some sort of statements inside our Java program before we know how many elements we need. Now, the array2 will reserve elements based on the size variable. So if the size variable is 5, then I will have 5 elements. Now, this is some programming tips. You have normally when you define the name of the variable for that array, it's good to use a singular, not a plural. So a score 3, not a scores 3. So that's make some more conventions or reading convention if you are developing a program. So use the name as a singular. Initializing array when you're declaring it. So you can initialize the array, and it's recommended that once you define the array, you initialize it. You make sure that you put a value and make sure the state of the array or for all the value is initialized. So you can define an array without specifying the length, but the compiler will understand the length based on the initialized value you provide. Here, for example, we define double array called reading, and between the braces we provide 3 readings separated by comma, 5.1, 3.02, and 9.65. These are the readings. So the compiler will understand, will read the elements, and will understand that the reading array will have 3 elements from 0 to 2. Now, testing your knowledge here, we do some calculations and we store the value on X based on these calculations, and we ask the compiler to define an array of integers. But the number of elements there is also another arithmetic operations. Now, you have to remember this. If this arithmetic operations, which is x mod 5 plus 2, end with the double data type, compiler will give you error. So the expression or arithmetic expression between the square brackets should always retain int data type. So do you think this is a mistake here, or the compiler will go through and declare an array? If the compiler will allow you to do this, how many elements? 4 elements. That's true. Okay? What about this one? Here we didn't specify the length of units and the letter grade. We leave the task to the compiler. The compiler will read the initialized value and specify the number of elements that it's needed and declare the array based on that. So what's the length for the units and what's the length for the letter grade? Ten and 5. That's true. Now, normally we need to initialize the array. As I said, it's recommended for our programmers to initialize the array before using it. Now, you can rely on the Java compiler, but this initialization, I'm telling you, you should be careful because from machine to machine, initialization might be different. So, we can use the for loop to initialize the array. Here, for example, I define an integers array A, and I reserve 10 elements. So the length of this array is 10. and I go for loops. That is the beauty of the Java, where the length I already inside the array. On C++ or any other programming language, you have to send the array and you have to send the length of the array. Now, no, you can access the array by a.length. There is no parentheses. Array.length immediately. So as you can see, we go for loop from I is equal to 0, knowing that the index is start from 0 up to the length minus 1. So the length is 10 up to 9. So this is the for loop. We'll go through all the elements inside this array and initialize them by 0. Do not count on the default initialized value. You can try it at home and see. If you leave the array uninitialized, see what's the values, okay? So, you cannot do this. Either to declare the array and initialize it in one sentence, you cannot break this. So I hope the slide is clear enough to see the difference and what's the mistake here. You ask for my array and then later on your initialization. The initialization and declaration of array should be in one sentence. Okay? You cannot do this. Array of other data types. So here we can see the double array results with 5 elements, and we initialize them. Now Booleans we can define, assign them. So the only thing here is this slide is saying not all the arrays that we're going to come across on this course integer arrays. We have doubles, we have Booleans arrays, and we have rectangular arrays. So you have different types. So you can use the array with any data types, with any primitive data type also. Summary, the values held in the array, it's called elements, and the array store multiple values of the same data type. So you cannot have an array where element 1 is integer, element 2 is double, element 3 is Boolean, element 4 is rectangle. This is not an array. Then you have to go to collections. We're going to cover it later on at the end of the semester. That's collections allow you to store multiple objects, but Java already stopped doing this. Okay, so in Java, array is more than a primitive type, but less than objects. And once the array is created, it has a fixed length. It's run from 0 up to n minus 1. We cannot change the length. If you want to extend the array or shrink the array, you have to create a new one with a new length. If you try to access an element outside the bound of the element, you will have array index out of bound exception, which is a runtime. Now, it's happened that people try to figure out, and most of the machines now, if you ask for an integer array without initializing it, it ends up with 0. But again, remember my notes, you cannot rely on this. You can assume, but you have to make sure that whenever you have integer is 0. If you have double is 1.0, and if you have Boolean is false, and string is not, because string is an object.
You said that the length in the only defined one setting is not the undefined length of the same array, right?
Yes.
But what about the value of the element? Can that be fixed?
Yes, you can change the value of elements. So you can ask for array of 5 elements of integers, and once you have 5 elements, you cannot extend this to be 6 elements. You have to create a new one. But these 5 elements, you can change them during the execution. I can store 5, 3, 4, 7, whatever I like inside these values. Value can be changed, but the length is fixed. Good questions. Okay. Now, if you are using an array of rectangles, you can rely on that they are initialized with the null. Okay? All elements are initialized by null. So quickly, I'm going to go through this slide. this slide is to test our knowledge to trace the executions of a certain Java program, where in this Java program we are using array. As you can see, we define array of values of 5 elements. So we go through the for loops and we ask that the values of the array, we assume the initial value of the is zeros, as you can see on the right side, and I plus the value minus 1. You would like to take 2 minutes and give me the content of the array by the end of the execution. Take 2 minutes, work on team if you would like. We start with 5 elements, 0, 0, 0, 0. After this program is running, what is the content of the array? Take 2 minutes. If you are able to solve this, then you understand what is the array is, and you understand how to use for loop with array to access each element of the array. And then as you can see, we have update the element of the array. Yeah, we need, so the first element is what? Element at 0. What's the value of element 0? 1. Element 2, element 1. Element 0 is 2. What is element 1? Okay, let's trace the executions. We start by defining the array. Then we have initialize I to become 1. Then I is less than 5. That's true. We're going to go inside the for loop. Then I plus value of I minus 1. That will become element 1 is equal to 1. We go increment by 1. Then we check the condition, still valid. Let's go back again to the loop. We have I plus, I in this case is what? 2. 2 plus 1 is 3. We increment, we check the conditions. Yes, 3 is less than 5. Go back again. 3 plus 3 is equal to 6. Go back, finish the loops. Is that right? Why I finish the loops soon? I don't know why. Anyway, one iteration is skipped. Then we have, after that, we set the value for 0 to 1, 11. So 11. Okay? So, simple question like this is tracing the execution of array and start with a set of values initially, run the program, and then come up with the content of the array after running the programs. Okay, now the array as an argument for the method call. Yes? Okay, so the array as an argument. You can send an array as an argument to the method. As you can see here, we have show array, and the argument, the input argument is car, and we provide the square brackets. So the car square bracket is different from car. So car square bracket is an array of car, and inside this, you see in the lines, we define a car, grades, 45 elements, and then we send them to my class.show array. We send the grades, but the receiving data type and the receive method show array should be matched with the data type of the grade. So what's the data type of the grade? Is a car array. So we have car with the square brackets, and we can receive it with any name. We should not, you can change it, you can receive it with a grades name, or you can put A, B, C, whatever you like. You run it through the length and you print it out. So array as a parameter can be passed as a parameter to the method. It's like an object. That is the good things about the array, is when you send the array, you send the reference where the array is stored. So you can handle the element of the array. So changing the element within the method can change the original value, because you are sending the actual address where the actual values are stored. So it's calling what we call, some people, by reference. So this is called by reference, not by value. When you send the array to the method, you not make a copy of this array and send it. No, you send where this array is stored in your memory, so the method have like access to the original element of the array. And if the method change the element of the array, it will change the original ones. Okay, this is an example to demonstrate this fact. We start with an integer array, only two elements, 1 and 2. And then we ask to print element 1 and 2, element 0 and element 1, and then we call a swap method. Swap method receive an integer array, and it asks a question. If the source is not null, if the array that I'm receiving is not null, that means the array is created, and the length of this array is 2, then I'm going to do the swap operations. I'm going to take the element number 1 and put it inside element 0, put it in element 1, and element 1, put it in element 0. So as you can see, when I send the array, I send the original location where the array is stored in the memory. So the swap will change the original content of the array when I return from the swap. Once I return from the swap method, I am asked to print the content of the array. So this example will test our knowledge that once we call a method and we send an array, we send actually the location and element of the array. We're not creating a copy of it. We send the actual location where the array is stored, and once we finish the swap, we swap the actual values, the original value of the array. So as you can see, we send num data type, which is int with a square bracket. Don't forget the square brackets. Then the answer will be swap. We swap the original values. Okay? Any question? Now, if you would like to copy the array, you define list 1 and list 2. So there is a content for the list 1 and there is a content for the list 2. And you say, oh, I want to create another copy of it. Then someone say to you, okay, use the equal sign. Equal sign will be a good candidate on this one. You told him, if I use that, I will create an alias, because array is a reference. I'm not creating a copy. The only thing here is saying that list 1 is pointing to the content of list 1. When I say list 2 is equal to list 1, it's saying that list 1 and list 2 are going to point to the same content. They're not creating another copy of it. And actually, the list 2 content going to go to the garbage at the end. So nobody going to access the content 2. So equals or a sign statement will not create a copy of the array. There is another procedure to create a copy of the array. So if we would like to use equal with array name, we are creating aliasing. So here we create A and P, two arrays of 3 elements, and we initialize the element of A in the for loop. And then we say P is equal to A, and then we change the element of A. Go to element number 2, and we change the value to 10. And we try to print the values. Now, based on the previous slide, the concept of aliasing, so A and P are actually pointing to the same content. They are not creating a copy. Equal sign will not create a copy. So what do you think the output of this? Element 2 is updated, initially is assigned to which value? What's the value of element 2? A2. And what's the value of P2? the first thing to know, the assign will not create a copy of the array. So both array gonna represent the same content, and both gonna print the same thing. Even the statement I ask A and change the content of element 2 to 10, but actually A and P are pointing to the same content. Because equal sign create an alias. So both A and P are pointing to the same content. I'm not creating a copy of array A and assign it to P. Okay? Now, remember that you can also retain an array from the method. As you can take array as an input argument, you can retain an array as an input argument. Here is the method where reverse the array. I take the array and I retain a reverse copy of it. To be able to do this, I have to create a new array. As you can see, the first line is called int array and result, a new int with the list.length. So the length of the result will be equal to the same length of the input arguments. And then inside this, I go for loops. I start from I 0 and j is equal to the result length minus 1. I have two variables inside this for loops, and for I less than length, I increment I and then decrement j. So those two index, they are working together inside the for loop. One for the original list that I want to copy, j for the second array that I would like to reverse. So result responsible, we have j, and for the list we have I. How I call this one? I say int list1, I define a new list of integers, and then I have int list2 and reverse. Now the reverse retain data type is an integer array. So I can assign the retain type from the reverse method to list2. Okay? Any questions about retaining an array? And now we end up with a new things about Java. We discussed that whenever we create a method, we can retain only one value from the Java method. Now using an array, we can retain multiple values with the same data type. So you remember, we have the declare methods only retain one value of a certain data type. If the retained data type is integers, we can retain only one value. By using int array, we can retain multiple value. By doing this example, for example, we can retain 6 values at the same time. Okay? Copying the array, either to create your own method that go through all the elements of the array and create a copy of that array. This is a trace executions for the reverse. You start with an array 1, 2, 3, 4, and 5, and in this array you would like to reverse this array. So as you can see in the first line, we create a new array of integers, results, and all the element of assume as 0, and we go inside the for loops. I is equal to 0, j is equal to 5, j is responsible to store the result on the result, and I is responsible to take the value from the list, which is the input arguments. If the I is less than the list, that's true, and we go assign the first element to the last one, because we assign it to the j. J is initialized to the length minus 1. Now we increment I, we decrement j. We ask if I is less than the length, that's true. We go back and assign the second element. So if you trace this execution of the reverse, you will end up with reversing the array. Any questions about reverse method? Okay. Yeah. So once you end up, you can see that the list 2 is equal to reverse list 1. So reverse will retain a new array of integers and assign it to list 2. So the list 2 and result, they are actually alias name to the same content. So you can use, but the result is actually locally will be destroyed, and you will have end up with result list 2. List 2 will be pointing to the new array. Okay? Then to be able to retain a new array, you have to create the array, unless if you are retaining the original one. Any question about reverse? Okay, so the behavior of three operations with a primitive data type is copying the content, with a class could be the address, and with array could be the address, with element depend on the element. Because if you are using a sign operator with a array of rectangles, this element is actually a class data type, so it will be a copying address. If you are using an array of primitive data type, so it will follow the primitive data type, which could be the content. So the assign operators has different behavior. If you are using a assign operator with a primitive, you could be the content. With a class, you could be the address. With the array, you are copying the address. Now, for equality, if you are assign used with the primitive data type, you are comparing the content. So two primitive data type equal, you compare the content. With the class, you compare the address, if they are the same address or not. With the class, with the array, you compare the address. With the element, depends on the element. Now, if you are using the parameter passings, if you are using primitive data and you send it to the method, you will send it by value. You create a copy of it and you send it. But if you are using with a class or array, you are actually sending a reference, sending where is the actual object or actual array is stored. You have to be careful. Now, this is an example where we have equal with an array. You define A and P, two integer array, and you initialize the content of these two arrays to 0. So you are knowing as a programmer that the content of A is the same as the content of P. You try to use equal. If A is equal to P, to say if these two arrays are equal. This will end up with what? What do you think the output of this? These two arrays are two different objects, and when we use equal, we are trying to say that they are stored in the same memory locations. We compare the addresses. So this will end up with array is does not equal, because we are comparing the location of the memory. A is located on a different location of P, but yes, the content are the same. If you would like to compare the content, there is a different approach, either to go with element by element and make sure that these elements are equal. Even if you would like to use dot equals with array, it will retain false. So there is another way, limitation. This is one of the limitation of for the array. Another limitation is you cannot print the array using a system.out.print line. If you ask to print array, it will print some random address on the memory. So to be able to print the array, you have to go through all the loops and print them out. If you would like to implement a method that tests the array for equalities, then we have to go through this method. This method is taking two arrays, A and P, as an input, and go through all the elements. So the first question is saying if array A is equal to array P in terms of length, if that's okay, then we're going to go inside and compare elements. If they are different in terms of the length, there is no point of comparing them because they are different in terms of length. So we're going to retain false. But if they have the same length, then it's worthy to go inside and check the elements, and we go with a while loop with the conditions match inside the while loop. So the match will be part of the conditions, and once the match has become false, everything will become out of the loop. This will optimize the executions. So I don't need to run for all the elements. As long as I find one element is not equal, I will stop. Any questions about how we can check the arrays for equality? And in this case, we are using a primitive data type int. Imagine the same scenario. We ask for two arrays of rectangles. So we have two arrays of rectangles. We have to go through each one of them and see if the rectangle this is equal to another rectangle. We're going to use dot equals method. Yes? Any question? Okay. Now, to make things more easier for us, Java expert create a class called arrays class. It's part of java.util class. This arrays class allow us to do binary search, copy off, so we can take an array and copy it and check two arrays for equalities. So we don't need to implement this. We can ask arrays.equals, and then we send array 1 and array 2 and return true if these two arrays are equal. Also, we can fill the arrays. We have an array that is defined, and we can fill it with a certain value. We can sort the arrays. We can have some values and sort them. And even if this array is an object array, like rectangular array, you can use sort and it will look for compare to and will sort rectangle based on the compare to methods. We can toString array. This will allow us to print the array without using the for loops. Let's see. This is an example where we define an integer array of 8 elements and we assign some values, and when we ask some element, number 1, to be assigned to x, and then we use that x to assign an element to value 42. Then I ask to print the element. What do you think the output of this? This example to test our knowledge that if we are using subscript to address the element of the array, we can use 1, 4, or 6, or we can use a variable x, or we can use another element to index the element of the array. As you can see, the number 6 element, or the element at 6, is used to assign 11 at that locations. So this will be 0, 3, 11, 42, 99, and 0, 2, 0. Now, this tests our knowledge that we have arrays is defined, and some of them is initialized, some of them is not initialized, and we would like to print the length. What's the content of A? What's the length of P? And what's the length for C? The content of C of A is 0, 0. The P has 3 elements, and 1, 2, 3, and C will be 0, 10, 20, and 30, and 40. Now, these two arrays, and we have array A, and we initialize the values, then we ask if element of I is greater than element of I plus 1, then if that's true, we assign a value to element I plus 1. And then as you can see, I use arrays dot toString with A. So I will print array using arrays dot toString. So I don't need to go through for loop to print the element of array. I use the arrays to print it out.
What is the answer to the previous one? Not this one.
Now, this is a problem. We have an array is given to us and we need to compute the average. So we have an array 1, 2, 3, 4, and 5. We receive an array of integers and we would like to compute and retain the average. So we need to implement public static doubles compute average, and we receive an array of numbers as an input argument. So we have to provide the implementation of this method. this one of the possible implementations. By going through all the elements of the array, we have access to the length of the array, numbers dot length, and we add the element to the sum. Sum is defined as an integer, and then we define double as an average, and we do the double divisions. Without the casting it, we will end up with the wrong result. So I recommend all of you to go at home and see if we cast without doubles. Okay? Now, this is another implementation for the same methods, but this students is decided to see if the length of the array is equal to 0, I will raise an exception, runtime exception. The array has a length 0, so I will avoid dividing by 0. Okay, it's taking care of this at the beginning, so to make sure that this array has some length before running the computations. Now, the rest of the slides, it's about exercises and test your knowledge. So I will leave them for you, and we'll continue from that next week.